So, to finish off the topic roots of polynomials, I'm going to talk through objective 3, which is the factor theorem. And more specifically, after this objective, you should be able to use synthetic division to evaluate functions and to prove factors exist for specific functions. Alright, so similar to the remainder theorem, the factor theorem states that if there is no remainder, or a remainder of 0, after dividing the function by k, the polynomial or factor x minus k is indeed a factor of the given polynomial. So, let's actually talk through what that looks like, because those are a little hard to follow. All that's saying is that if I'm given a factor and I want to see that if it is indeed a factor of a polynomial, I have to divide it out of that polynomial, and if I do that and the remainder is 0, then I know that the factor given is a factor of the polynomial as well. So, examples. The one I'm going to do for you, I've listed the steps in red on the right here, and it says, given x minus 2 is indeed a factor of the following polynomial, factor out the rest of it, factor the entire function completely. So in this case, we're told that x minus 2 is a factor. But I'm still going to check to make sure that it is, just to show you that process, because when you practice this, you're going to have to be able to check to see if it's a factor or not. Under the remainder theorem, if you remember back to objective 2, it was asking us to evaluate a specific value, x equals negative 3. Here, it's asking us to evaluate a factor, x minus 2. So the first step in this process to synthetically divide, because we're still going to use synthetic division, is to change factor form to root form over here. Because again, with synthetic division, if I draw my synthetic division box, which is step 2, what goes right here has to be the root form, not the factored form. So I can set my factor x equal minus 2 equal to 0 and solve for x. Plus 2, x equals 2 is the root form. So I now put 2 outside of my synthetic division box. So I've just done step 1. So that should be on a test or a quiz. If it says evaluate or divide out and it gives you a factor, you should know that you have to change from factored form to root form. If it gives you just a value, x equals a number, you can just use that number and put it here because it's already in root form. So please keep that in mind as you're working through these types of problems. And then step 2, it says synthetically divide out the root. So this is review from objective 2. But I'm going to show you how I would do this again. So I've already put it into root form. I have 2 as my divisor right here. And I'm going to list out my coefficients on top up here of the polynomial in question. So the coefficient of 1, even though it's not written, but I know that it's a 1 if it doesn't show up. Then I have to check the powers. It goes from x cubed to x squared, so there's no jumping of powers, so I can use 6 as my next one. There's no space holder of 0 needed. And it goes from x squared to the linear x to the 1. So again, no space holders needed, but I have a negative 1 here. So I have to write negative 1 because of that subtraction. And then finally, it goes to the constant negative 30. And again, if you remember, the way to check yourself is I have 1, 2, 3, 4 numbers in my synthetic division box, and the highest power was 3. These numbers need to be greater than by 1 of the highest power, so 4 is greater than 3 by 1. So I did that right. I have 1 more than the highest power, so I did that right. So I have set up my synthetic division box, and now I need to actually do the process to check for the remainder. And we're looking for a remainder of 0 to see if this is going to be a factor. I drop down my 1, I multiply to the outside, add to the inside, so 2 times 1 is 1. Line it up right underneath the next number. 6 plus 1 is 7, and then 2 times 7 is 14, and right underneath the next number, negative 1 plus 14 is 13. Wait a minute, I made a mistake. Hopefully you saw it as I was working through. 2 times 1 is not 1, it is 2. Alright. 2 times 1 is 2. 6 plus 2 is 8. 2 times 8 is 16. There we go. Negative 1 plus 16 is 15. At that point, when I did that wrong, I was thinking to myself, I should get 0 for a remainder, and it didn't look like the math was going to work out. That's how I kind of knew that I had made a mistake. All right, finally, 2 times 15 is 30. And at this point, I draw my remainder box because there's no more multiplying to do. And I add the final two numbers, negative 30 plus 30 is 0. So I do have a remainder of 0, which means the factor in question, x minus 2, is a factor, and the root, x equals 2, is a root of the polynomial. Two things we've just found out, which is pretty cool. Now, I did that. In the final directions, say factor out the entire function completely. Now, for this objective, what I really want you to be able to do is just get to this step I'm about to show you, which is step 3. If no remainder, which is true, we just found that there's no remainder of 0, then rewrite the new polynomial and factor completely. Even if there is a remainder, you should still rewrite the polynomial and factor completely. But if there is a remainder, you won't be able to factor completely, but you can still rewrite this process for your final answer. So in order to rewrite, I started with the power of 3, x cubed, my original function. Every time you synthetically divide, you lose the highest power by 1. All right? So now I'm going to add my variables to my numbers down here. And instead of x cubed, I'm going to write x squared because you lose it by 1 because we factored out or divided out a factor. And then it goes down the line. So since I started with x squared, it's now going to be just x. If I started with x cubed, then the next one would be x squared. But we just have to go down the line from x squared to x, and then my constant 15 doesn't get a variable because we've ran out at x to the 1. So let me rewrite this nice. I have x squared plus 8x plus 15. That is my new polynomial after I divided out the factor of x minus 2. And hopefully this, if you can get to this, that's great. That's what I need you to be able to do for this objective. But to move further from this objective, if you can recognize that that is a quadratic trinomial, and the directions state factor the entire function completely, if there's no remainder, which there wasn't. So I can use mac ab to factor this completely. So my mac is 15, my ab is 8. Go ahead and pause the video and try to factor this completely. Because if you see, you're gonna actually move into the next step, which is solving polynomials. We've already found one solution right here. And hopefully from the fundamental theorem of algebra, you can see that we're looking for 3 solutions because the highest power is 3. So if we factor and solve this new quadratic trinomial, we should discover our next 2 solutions. All right, so pause it, try to factor it on your own, and then solve each factor, set them equal to 0, and then unpause it and check your work with mine. All right. At this point, you should have paused the video to try to factor this on your own. I'll start and show you my work or my thought process. I always start with 15 divided, or the number in question, 15 divided by 1, which is 15. 1 times 15 is 15. 1 plus 15 is not 8. Try the next number after 1, which is 2. 15 divided by 2 is not a whole number, so that's not a factor. Then try the next number after 2, which is 3. 15 divided by 3 is 5. And it looks like a winner. 3 plus 5 is 8. So I have my next 2 factors. I have, and again, I can write the whole thing in factored form. So I'm going to put y equals my first factor, which was the one in question that we synthetically divided. So x minus 2 times my new factors that I found. This is a positive 3 and a positive 5. So I would have x plus 3 and x plus 5. That's in factored form. Now, to go a little bit further, hopefully you even got to discover the roots of this polynomial. X equals 2, x equals negative 3, and x equals negative 5. Please raise your hand at this point if your work doesn't look like mine for this part, because this skill is necessary for the next objective or the next topic. All right, moving on though, again, to re-hit this objective, I want you to be able to check to see if factors are factors of a given polynomial. So I'm going to have you practice the skill of synthetically dividing to check for a remainder again. And so in this case, it's giving us 2 factors in the question of this polynomial. So if that's the process, and you'll learn this in the next topic as well, you can synthetically divide more than 1 time. All right? It does not matter how many times you do the process. And it doesn't matter which factor, which root you would use to go first either. So I'm going to start with, first off, I got to do this first step again, and I'm going to just show you what this looks like and then have you practice the second part of this on your own. But I got to change from factors to roots, right? Because I use the roots. So for that, I have x minus 2. And I know that the root form then is x equals positive 2. And then I have x plus 3 as a factor. And I know the root form is x equals negative 3. So that's my first step, using the roots. Now, to synthetically divide, it does not matter which one I choose first. I can choose either one to go first. I'm going to pick 2. And then I'm going to list out my coefficients on the top. Looks like it goes from 4 to 3 to 2 to 1 to 0, so I don't need any space holders. So I just have 2, 7, negative 4, negative 27, negative 18. All right, so I drop my first one. Go ahead and, actually, this should be a skill you've developed by now. So go ahead and pause the video and try to synthetically divide on your own to get the new numbers down here, all right? At that point, unpause the video and check your work with mine. So go ahead and pause the video at this point. So, you should have paused the video by now, so please check your work with mine. I multiply to the outside, add to the inside, drop the 2 down. 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. Negative 4 plus 22 is 18. 2 times 18 is 36. Negative 27 plus 36 is 9, positive 9. And finally, 2 times 9 is 18. Draw my remainder box. Negative 18 plus 18 is 0. So the first root, or the first factor, x minus 2 or x equals 2, is indeed a factor and a root. So far, so good. Now, at this point, technically the new learning, because you can synthetically divide twice if you want to, I would just draw another synthetic division box outside of my new numbers, all right? And then here, I'm going to evaluate the next root, which is negative 3. And then it's the same process. So, at this point, you should be able to drop the 2 down, you multiply to the outside, add to the inside. You should be able to give me the new numbers that you have for a polynomial, and then even get to this step where you rewrite the polynomial in its new form after you've divided out twice. But please be aware that we're synthetically dividing 2 times. So our new polynomial down here will have what as its power? We started with 4, and again, every time you synthetically divide, you lose a power. So what's going to be its new power down there? Keep that in mind as you're working. So go ahead and pause the video one last time and try to synthetically divide, and your final answer should be a rewritten polynomial down here, all right? At this point, you should have paused the video and tried to synthetically divide negative 3 from your new numbers up here, 2, 11, and 18, and 9. Please check your work. I wrote my work in blue, all right? So I did negative 3 times 2 gave me a negative 6. Then I added to 5. Negative 3 times 5 is negative 15. Then I added to get positive 3. 18 plus negative 15 is 3. Then negative 3 times 3 is a negative 9. Added one more time. 9 plus a negative 9 does give me a remainder of 0. So this is where you check your work after you did that. In purple then, I added my new variables to the numbers I had left over. Again, we synthetically divided twice, so it started with the highest power of 4. Now I lose 2 powers because we did it twice, so it's the highest power of 2. And this should be what you get for your final answer, 2x squared plus 5x plus 3. If you didn't get that, please raise your hand so I can check your work.